Welcome to a stoichiometry problem. This is example number 2 in our class. So we're going to go over this here. I'm going to read the question, and we're going to go through all the steps and do the stoichiometry. Okay, so here's the question. It says glucose, right here, this is glucose, is used as a source of energy by the human body. The overall reaction in the body is this. Now, we're going to check to see if this is correct, okay, because I've actually left something out on purpose. Maybe you've noticed what's wrong yet, but what it says is we're going to calculate the number of grams of oxygen. So here's oxygen, and we want the number of grams. So notice how I'm doing this. I'm going to start my flow chart. As soon as I read it, I'm going to start filling out my flow chart. How many grams of oxygen needed to oxidize 12.5 grams of glucose? So guess what? I'm given 12.5 grams. So again, we're using the flow chart method here, and I'm going to put my givens sort of right underneath my equation. And so that's what it is. And it produces carbon dioxide and water. Now, we have to make sure that we have a balanced equation. So is this equation, first of all, written correctly, the formulas of all reactants and products? Yes, they're written correctly. Is it balanced? No. What else do we need here to make this? Very good. We need a 6 there. Okay, good job. Please check to make sure that everything is written correctly and balanced. We need a balanced equation. And anything else here? Okay, well, we'll put a 1 there. Yes, thank you. I really do appreciate when you put 1s. So good. Good job. All right. Now, it just so happens that we are actually, for this question, we are not going to be concerned at all with these guys over here. They're not involved in the question. Yes, we need to balance the equation because I need to know the coefficients involved in the chemicals or the substances that we are concerned about here. But just so you know that there are obviously some things in the equation that you're not going to deal with at all in every question. So just so you know, we're not actually going to worry about these guys. Because see, we're asked for this in grams, and we're given this in grams. So our flow chart is going to look like this. And this is what I do next. Arrow down. Because we have to convert everything always to what? We have to convert to moles by, yes, using grams per mole. But we have to convert to moles. And then, so the flow chart looks like this, and this is honestly what I do and what I ask you guys to do. So moles to moles, and that's going to be moles of O2. This is going to be moles of sugar. And then I'm going to have to go to grams. So this is the flowchart method, and if you kind of set this up like this, you are setting yourself up for success. You're going to make very few mistakes. This is going to be very good for you to see exactly sort of what step to take and when, because you follow the arrows, you see these nice arrows, and you have all your work kind of laid out. Okay, so how do I convert from grams to moles? What do I do? Grams to moles. I'm going 2 moles, so I always, what? Divide or multiply? Always divide. Always divide when you're going to moles. So I'm going to divide by the grams per mole, right, of glucose. Okay? So let's just take a moment to figure that out. So this is what I got here, 0.069383 moles. And that's 12.5, my given grams, divided by the sum of all of these right here. So 6 times the mass of carbon plus 12 times the mass of hydrogen plus 6 times the mass of oxygen. Okay, who else got that number? Yeah? Okay. Was there a lot of you that got a different number? No. Okay, so we can say this is good. All right, so what does this number represent again? What is that? The number of moles, okay? 0.0693836, okay. 0.0693836. And write as many decimal places as you can. Of course, again, keep the number on your calculator screen there so you can use the whole decimal. That's always best. All right. We good with that so far? We've calculated moles. Now, where does our flow chart tell us to go? Moles to moles. Right? Yeah, you're right. And multiply. So what are we going to multiply? This number is going to multiply by, it's by 6. Exactly. And what's that ratio sort of method? We go, hey, it's going to multiply by this coefficient that we're going to, 6, divided by the coefficient we're coming from. And that always works. You'll never have an issue if you always do that. And yes, we're just multiplying by 6. So you just don't retype the number. Just keep it on and just do times 6 equals. Okay, and this is going to be the new number of moles of oxygen that we should produce according to this ratio. So 0.41, what was it? 6 what? 6.3 something. Okay. Again, we'll keep that on our screen. Use the whole decimal. You guys follow me so far? Is this good? Easy? Yeah? All right. Awesome. So now I need to go from moles to grams. So what do I do to convert from moles to grams? I multiply by grams per mole. And of course it's going to be grams per mole of oxygen. Yeah, don't worry about this one now. Glucose is out of the picture, okay? We don't have to worry about this anymore. Now we're just dealing with oxygen. So O2 is 2 times 15.9994. So times 2 times 15.9994. So we've got 13.32. Does that look about right? Okay, so up here then, that's 13.32 and whatever grams. All right, now the only final thing we want to do is look at sig figs and round to the proper number of sig figs. So actually I can write this. Sorry? Yeah, it is. 13.3 grams. And you should say of what? Okay, 13.3 grams of oxygen. Is that agreed upon? Does that look good? Okay, so there you did another stoichiometry question. That's awesome. So that's a mass to mass one. And that's as tough as you're going to get, really. Other ones may be a little bit easier, but don't let them throw you off. They may give you the number of moles. Okay, you may be given moles and asked to find moles of a product. What that means is you don't have to worry about this conversion first. You're going to go straight to this step. And you're going to go over to here to this step, and then you're going to be done. So some questions may be easier than this one. All right? Okay, so here's a question you can do on your own according to the equation below. How many grams of ammonia, and that's this one right here, how many grams of ammonia is produced from 3.41 grams of H2 in lots of nitrogen? So here's how you start, and I'll let you take it from there, guys.